les collègues talentueux ce que se passe en Égypte pour les grands projets. Merci et je dois switch to the English. Well, mega project in Egypt, and I am going to concentrate on to highlight on three projects. One is a cable-stayed bridge, the other is 2 tunnels under Suez Canal, and a landmark, really, comme on dit un projet phare, c'est the Grand Museum of the Grand Egyptian Museum. The revolution in January 2011 took its toll on the Egyptian economy, resulting in a slowdown that was reflected in deterioration of the real GDP growth rate and the increase of unemployment. Furthermore, total investment witnessed a material downward trend, and the country's foreign reserves were depleted significantly. And this shows how really the employment increased after the revolution and the collapse of the Egyptian economy. Consequently, the rating agencies downgrade Egypt's sovereign rating by around 6 notches during the period from January 2011 to July 2013. You can see how also this downgrade. We find that the only way to energize and to activate our economy is going for mega projects. During the last 4 years, mega projects in Egypt are diversified. We started with a very big project, is the doubling of Canal Suez. We dig a new canal parallel to the existing canal, and millions of dredging meter cube. And during this period, we used 22 dredgers, and we achieved this project in 1 year. The second one is electrical power station plants. We add to our grid 25,000 megawatt in 4 years, and I think this is the biggest project in the field of electrical generation. Affordable houses, 1 million units are planned to be added. We achieved till now 650,000 units. New roadways, 7,000 kilometers are added to our network in 4 years. And this also, I think, it's very remarkable project in Egypt. Reclamation of the desert. We add 1 million acres to be reclaimed in the desert. New cities, 14 new cities spread all over Egypt. And a new administrative capital is now under construction. That means that really Egypt now is a very big site, working 24 hours, 7 days per week. Fisheries, we established a big fishery, 3,000 acres in north of Egypt. Restoration of heritage and monuments. Also, Egypt is full of heritage and monuments, and now we start to restore it. Mega project in Egypt, maybe Road al-Farah cable-stayed bridge is a remarkable bridge which we can really present, and the 2 other tunnels under Suez Canal, we have to highlight those, and this is a Grand Egyptian Museum. Our motto is quality, equal, should fit to purpose. And this was the concept of our thinking. Technical aspects, economical aspects, formal aspect, and environmental. Those are the 4 factors we worked, because we don't have really time, and it is a question of how to select, during this, the most optimized, the most economical project, and to start immediately construct. Design condition, functions, client wish, budget, resources, location, construction, give us the design aspects, design alternatives. Always we have to think about the value engineering and to choose the most really optimized project. Always there was a committee from the object design team, architect, client, contractor, project, and management. This was a permanent team working to select the most economical project. It gave us the evaluation of alternative and the decision making, and decision was taken really in a very short time, and this was the big challenge. Road al-Farag corridor is a corridor, is two stages. First stage, we have now we have to go to Egypt now. Okay, sorry. This corridor is two stages. The first stage is 29 kilometers of routes. This is linking the west and the east of Cairo. The first stage was an elevated route, 29 kilometers of routes elevated, with 9 small viaducts and 12 underpass and tunnels. This was sector 1. Sector 2 is 5 bridges. The stage 2 is 5 sectors. The first one is a bridge, precast beams. Second one is a cantilever carriage stressed bridge crossing the Nile. Third one is also viaduct crossing an island. The fourth one is a viaduct crossing a very congested area in Egypt is Shubra. The cable-stayed bridge is sector 4. This cable-stayed bridge really is very special because it is the first cable-stayed bridge crossing the Nile. The bridge has a semi-floating bearing system in the longitudinal and transverse direction. The bridge is floating in the longitudinal direction in which the wind and seismic loads are carried by cables and towers, while the bridge is supported transversely by bearings to carry transverse loads due to seismic and wind loads. The side span of the bridge has concrete box section to work as a counterweight to the main spans under live loads, although its arrangement is not usual for such side span to span ratio of 0.4. In construction due to the bridge heavy cross-section, which constructed using a rigid temporary force work, which was specially designed and constructed for supporting those heavy loads. The bridge also maybe one of the widest bridge in the world because the wide is varies from 64 up to 88 meters. Those are this is the height of the bridge pylons. It was constructed by climbing form. Every segment is 4.5 meters. The 95 height two pylons have hollow concrete cross section. The construction of pylons was carried out using self-climbing formwork Each pylon leg was divided into 20 casting segments with height of 4.5 meters for each segment, with 6 platforms, as is considered as the heights of this construction type. And the figures shows respectively the pylon cross-section segment and adopted self-climbing formwork. This is the pylon head. This is a steel pylon head. The top cable anchorage are implemented in steel boxes units that work as the inner shuttering of the pylon head. This was fabricated outside in a workshop, and because the angle and the accuracy, maybe the tolerance is almost zero tolerance. And this is really the pre-assembly of units for geometry control. The pylon head erection, after assembling it in the pre-assembled workshop, we are transferring it to the site and starting the erection. The deck segment in main span, 20 segments of steel composite open section of 14-meter length. The segment height of about, every segment height was about 180 tons. Precast concrete spans are arranged on segment top, and this was also pre-assembled in pre-assembled workshop. Then we have to transfer it by barge and to lift it to the site. The steel deck anchorage. This is the steel deck anchorage. Deck anchorage fabrication, consideration of sag angles and cables and final geometry of the deck, fully tested welds using ultrasonic. The main span deck segment pre-assembled in the yard. We are assembling 3 segments, and all the holes are fitted at the workshop. This is how we are assembling the deck segment in the yard. The cross beams, then moved. The other segment is come. This is the second segment, because this is very accurate how to fit, that the holes are, when we are assembling it as a site, should be accurate 100%. And the third segment is coming. Then we are lifting it by cranes. Putting the segment on the barge. And going to the site to be assembled, the site. We have used 2 launching girder for each segment. Every launching girder, the capacity was 90 tons. This is the erection of the steel segment using the launching girder. Then we add the precast slabs, and then we are stitching the slab. The construction of the deck inside span, it was an RC deck box section inside span. The total width varies from 65 meters to 88 meters. And this is the heavy shuttering and scaffolding for the deck span. This is a concreting of the site span. This shows the construction of the pylon. The main span was 300 meters, and two side spans 120 meters. This is a semi-floating bearing floating in the longitudinal and fixed in transverse direction. We have used what we call dumpers, spacer laid with boreholes, shear connection, a threaded pre-stressing bar spacer with bar holes was added in the pylon. And this is the 12 viscous dumpers in the pylon. Those for getting all the stresses coming from transverse and seismic stresses. This was the erection of the first cable, and now it is, I think, they start the erection of the second cable now in Egypt. Figures, total piling length, the diameter 2 meters and 1.5 meters. We have used 8 kilometers of piling and 15 kilometers of 1.5, 8 kilometers of 2 meter piling diameter, and 15 kilometers of 1.5 meter diameter. Total structure steel reach 10,000 tons. Total concrete volume 48,000 meter cube. The total reinforced steel 19,000 tons. The total stay cables 1,800 tons. This video is from the, okay. Going to another mega project. You know that in Egypt we have the Suez Canal is between the west and the east part. The east part is Sinai. The west part is, and this is, Sinai is in Asia. And always we have to cross the Canal Suez by bridges. And we construct a bridge, cable-stayed bridge over Canal Suez, but we need four tunnels. We are constructing now 4 tunnels under Suez Canal. Suez Canal is, for Egypt, is very important, not only for Egypt, but for all the world, because the location of Egypt is in the center of the world, linking the Red Sea with the Mediterranean, and the ocean, the Indian Ocean with the Atlantic Ocean. That means this is a very important location in the world. We thought about those 4 tunnels, and at the same time we are creating an economical, logistic, industrial zone in Egypt east of Suez Canal. The project purpose to establish access route started from the west of Egypt to the east of Egypt, direct, without crossing, without any obstacles. And to connect the international coast road with the west side of Suez Canal to reduce distance by 100 kilometers to cross canal according to current situation, and serve the East Port Said and investment-free area, providing new investment opportunities and accelerating the urban area in Sinai, encourage the citizen in the East Delta to be transferred, because Sinai is representing almost 6% of the area of Egypt, but there is no inhabited in Sinai. It's more or less than 500,000 the population. Egypt is 100 million. That's why we want to encourage people to go and to live in Sinai. Technical project challenge, tunneling is silty clay layers without affecting the navigation in the Suez Canal. This is very important, that we are constructing the tunnel without affecting the traffic navigation. The tunneling boring machine modification due to dissolved methane gas. This area is full of methane gas layers. And transfer the material, it was another challenge, how to transfer the material from the east, from the west to the east. Soil condition, we can see that this is the worst soil condition in Egypt is this area. The clay layer, very soft, highly plastic clay, 42 meters thick, with sand penetration values of less than 5. The sand layer, very dense quartz sand, 70 to 100 meters thick, and clay layer, hard silty clay, less than 3 meters thick with sand layer 2. Groundwater level above mean sea level chemical, and this area is chemically very aggressive. We start to make a kind of soil improvement, and we have to face the challenge methane gas, because the risk was very dangerous, or explosion, or fire risk and gas flooding. And to mitigate the risk, working group of all parties, we establish a review applicable codes and standards, and we investigate to define the gas hazard and options and modification in the tunneling boring machine. This is a project. In the middle, there is the north tunnel, south tunnel. Then we construct the luncheon, a luncheon shaft in the east side and a reception shaft in the west, plus a cut and cover area and an open security entrance. In figures, the road tunnels for Port Said, the diaphragm wall, the west 510 meters, the east 430 meters under Canal 0, overall 940 meters of diaphragm wall. Luncheon receiving and receiving shaft, the west 40 meters, the east 100 meters, and the overall 150 meters. And the tunnel itself, by the tunneling boring machine, was in the west 1 kilometer, almost 1 kilometer, 93 meters, and the east 1 kilometer, 150 meters, and the under Suez Canal 658 meters, and the total is 3.8 kilometers. This is a vertical alignment, and we can see that we are under the bed of Suez Canal, 24 meters under the bed. This is a cross-section of the tunneling machine. The diameter of the tunnel is 11.35 meters. We used 14 diaphragm wall equipment. We used forming concrete equipment 48, excavation and backfilling equipment 56, joint equipment 76, soil injection equipment 8, mechanical works equipment 59, and overall there was 261 equipment at the site. This is the east luncheon shaft, and we can see that is due to the very bad soil. It was an arched shaft. This is the luncheon shaft. The TBM factory test, it was the tunneling boring machine. We start to assemble it at the site. This is when we finished, and this is the breaking out for the machine. This is a segment factory. The area of the factory, it was a huge factory, 10,000 meters square, production rate 15 rings per day, and the area of storage yard to 20,000 meter cube. Segment factory. This is the road deck. It was precast, and now we are fixing the road deck now in the tunnel. This is planned to be open mid of next year. This is the cut and cover and diaphragm and the struts. This is the cut and cover area. Major quantities, the tunnel boring works, 770,000 meter cube, excavation work, 1,500,000 meter cube, soil improvement work, 2,093,000 meter cube, diaphragm wall, 550,000 meter square, concrete works, 1,02,500 meter cube, reinforcement work, 105,000 ton, precast concrete rings, 129,000 meter cube, road deck concrete works, 40,000 meter square. From this figure, you can imagine the challenge, because we started in the year first at the beginning of 2016, and almost the tunnel is structurally finished. Last but not least is the Grand Museum. This is a Grand Museum on the plateau of the pyramid. It's far from the pyramid 2 kilometers. And really, the architecture thinking is, it was a competition, and this was the first prize. The architect design of the museum was based on the concept of pyramids, formation in both elevation and plan views. The main building footprint was planned based on the pyramid's plan grid lines. This is a relation between the structure and the monument, the pyramid. The site ranges regarding the three pyramids, starting from exact point at north and west, intersect with each forming of the building footprint. This is the idea, how the projection in elevation and plan intersect to create the location of the museum. There is an entrance courtyard. The entrance courtyard contains long span opening, mesh roof, primarily for shading. The entrance is located at the heart of the master plan. And if we look to, there is 27 components, but the structure itself is 1, 2, 3. Those are the structure, but the other are landscaping. The structure system of the roof is composed of long span steel trusses rested on movable elastometric bearings on reinforced concrete corbels, as shown in figures. The truss cross-section are made of box steel section with dimension ranges from 40 centimeter to 80 centimeter and thickness up to 9 centimeter. In the entrance, we put the statue of Ramses. And there is a history for the statue. This was relocated from a very congested area to the museum. And this is another project, but it will take a long time. This was diffused by more than 70, the relocation and the transportation of the city. It was diffused by 70 international television. This was the place, the original place in a congested area near the railway, but the pollution and the congestion forced us to relocate it, and we transferred this statue in the year 2006 to the site of the museum. This is really, it was, we took more than 1 year for the safe transportation of this statue. And this is in the year, this year we move it from the storage in the museum to the final place in the entrance. And we considered him as a king, and it was a small parade and festival to receive the King Ramses in his final place. This is the main place in the museum. This museum is planned as a museum of art craft of ancient Egypt, described as the largest archaeological museum in the world. The museum is under construction and is scheduled. The full structure is finished. Now we are in the finishing and the landscaping and electromechanics. This is the main building roof, which I described, the steel trusses. The main building roof. Gallery roof. Over the museum and conference center, a concrete folded plate roof together with external shaded void and internal ceiling void fill the roof volume, and this is shown in the photos. The main building structure system consists of steel beams grid with I-beam cross-section. The main beams are supported by the main trusses of the roof, while the secondary beams are rested on the main beams. This is the grand stairs. The grand stairs wall from two sets, and the people are going to sit it on the steps, and they can, from the steps, look to the pyramid. This is the facade. The structure system of the pyramid's wall is comprised of vertical steel grid of box steel sections aligned in the diagonal direction and supported on a reinforced concrete wall as shown in this figure. At the entrance opening, mega steel panels are used to support the facade cladding. During the construction, the fixation of steel diagradding in concrete wall was followed by mounting the stone piles. Those are transparent stone. In the sun, it will be transparent. In the night, it will be lighted behind between the steel trusses and the facade. at the same time, we have a big workshop in the museum for the conservation, and there is a conservation center of all the monuments are going to be exhibited in the project. There was a very strict environmental strategy in this project. Conclusion. We really achieved our goal. The improvement in the Egyptian economic indicators after downgrading now triggered and the rating agency to upgrade the sovereign rating of Egypt. And the rating agency, if you compare before, in the red, it was in 2013, and the green is 2018. That really mega project. They energize, they activate, they put life in the Egyptian economy. Thank you very much for your listen. Thank you very much.
Thank you very much, Mr. Prime Minister. I think that we could have listened to you for hours and hours.
Yes.
It was a very nice presentation about these huge works which have been undertaken, which are ongoing or achieved in Egypt, and it was really very interesting. I don't know if we have some minutes, maybe 1 minute for question, if any. Otherwise,
thank you.
Thank you very much. Is there any question? Yeah. It's difficult to see.
Michel Cahan from CETEC Engineering Consulting Company in France. Thank you, Mr. Prime Minister, for this fascinating presentation of mega projects. By the way, I'm glad that a civil engineer can be in one country in the world appointed as Prime Minister to enhance large projects and leave a trace in history. For just a technical question, I was curious about how you actually mitigated the risk of gas inflow while boring the tunnel below the canal.
Yes, this is a very important question. By daily analysis, by safety equipment, and by some modification in the TBM tunneling boring machine. We modified the tunneling boring machine. It was Herrenlicht. They came and they modified it, and it cost a lot, really, to add some devices to protect people from this gas. By the way, you mentioned about civil engineering and Prime Minister. Believe me, when I was appointed Prime Minister, it was a very dark period in Egypt, but with the project management, I success. Really, the civil engineering, believing in his project management, how to manage a site, if really with his experience, he can manage a really big country like Egypt. Thank you very much.
It is undoubtedly a great example of what could be done and could be managed between politicians and engineers.
I say always I am an engineer, I am not a politician. Thank you.
Mr. Prime Minister, please allow me to offer you this book on behalf of the organizing committee of Nantes, of IABSE Nantes 2018.
Thank you very much. Thank you.
Thank you very much. Welcome.
So before ending this opening ceremony, I would like to make a short presentation of the European Year of Civil Engineers. So I'm going to deliver a message of ECCE, which is the European Council of Civil Engineers, which supported this conference, and which was created. Yes, which was created in 1985 out of the common concern of the professional bodies for civil engineers in Europe, that the civil engineers working together across Europe could offer much more to assist Europe advance its built environment and protect the natural environment. So ECCE has 23 member country organization extending from Portugal to Georgia and from Estonia to Turkey, and 6 associate members. And it is associated with 8 other international engineering organizations. Last year, ECCE decided to designate 2018 as the European Year of Civil Engineers, in combination with the 200th anniversary of the UK Institution of Civil Engineers. During this year, ECCE wants to reinforce the fundamental role of civil engineers in society in improving the standard of human life from the old year until now. We accomplished this through many different types of projects, including dams and reservoirs, water distribution and treatment facilities, road networks and bridges, foot bridges, rail networks, energy generation and distribution facilities, but also stadiums and cultural and social facilities, and many others like airports. Finally, ECCE wants to stress the pivotal role that civil engineers will play in addressing the challenges that will face society in the future, including rapid urbanization, climate change, and the digital revolution. I hope this has given you a useful introduction to this year EYCE, the European Year of Civil Engineers. So it's time now to move to some main features of the organization of our symposium. First, I would like, of course, to thank our keynote lecturer, former Prime Minister Mr. Ibrahim Malab, Mrs. Christine Orin from the Department of Loire-Atlantique, and also I would like to mention Mr. Giver, which is the Swiss Consul of Nantes, and who is present in this auditorium. Of course, I would like to thank all our sponsors and the supporting organizations. And I'll give you now some final information of the organization and of this event. So please note that the two following important changes in the program of the symposium, with the Bentley session, Better Bridges from Beginning to End, presented by Lee Tanase, will be moved and will take place on Thursday in room J from 12 to 12:30. And the second change is the addition of a special conference entitled A Report on the Genoa Bridge Collapse, Background and Apparent Causes by Fabrizio Palmisano, the Politecnico di Bari. And it is supported by the TG 5.1 of IABSE on forensic structural engineering. Then would like to mention that on Wednesday, so today, from 19 to 22:30, the welcome reception will be for the Machine de Lille, in Les Machines de Lille, so in the island of Nantes. And the meeting is in front of Les Machines de Lille. So you have to go by foot or by tramway to the entrance of this big building. So you have a pass in your bag, and you can take the tramway at the station Duchesse Anne and get off at the station Chantier Naval. It's just close to this station. And for the return, I would like to mention that the last departure for tramway is at 23 hour and 11 minutes. Okay. Thursday, there is a gala dinner in the Château de la Pigossière, and we go there by bus, and the bus departure is at, as you see, 6:30, meeting in front of the Congress Center. In fact, it's not really in front of the Congress Center because the bus cannot stop in front of the door. So it's on the left, about 100 meters on the left, where you could see the bus to go to this castle. And then we come back by bus at 22 and 30 minutes. Concerning the technical visits, the first visit, wind tunnel of the CSTB and the swell basin of Central Nantes, the visit is full, and you see that the bus departure is at 2 o'clock, again in front of the Congress Center. And for technical visit 2, 3, and 4 and 5, there are still some places. And again, bus departure for the technical visit number 2 tomorrow morning at 9 o'clock. For the technical visit of the Saint-Nazaire Bridge tomorrow, the bus departure is at 8:30. So note that, and with a return by bus at 12. For the technical visit of the Cheviré Bridge, bus departure at 2 o'clock in the afternoon, and return at 5 o'clock. And finally, the technical visit for the new railway station of Nantes, which is a station made of ultra-high performance fiber reinforced concrete. The participants walk, so there is no bus. It's very close to here, and so participants walk to the train station. There is an application on smartphone named IABSE Nantes with the code that you see on the screen. Coffee breaks and lunches are served in the commercial exhibition space. And the opening and closing ceremonies, as maybe you saw, are filmed. And a lot of photos also are taken during the 3 days. And to finish all these informations, I would like to say that the next sessions are beginning at 10:30 in the 8 rooms, as you saw on your program. So now I close this opening ceremony. I thank you for your presence, and I wish you a good coffee break now.